Hello, I'd like to discuss the charter vote SQL project that I worked on. I created this using database normalization, or DBMS, and started off by going inside of the exercise and grabbing information that we want to pass into a table, putting that in note form so it's right there in front of me. Went ahead and entered in drop database if it says charter, create database charter, and use charter. Essentially what that does is it's going to remove any information. If there's a charter database already in existence, it's going to create the new charter, and then of course we want to use charter. Before we get into what you see in front of us, started off with the first normal form. That was kind of like a rough draft here, and was discarded afterwards, but just wanted to establish that there's every cell contained a stable value, that each record is unique, that we don't have any kind of repeat statements. And then we moved on to the second normal form. So we wanted to remain in that first normal form, which is not repeating anything. And then we also wanted a single column primary key. So we wanted to add that primary key to the data as well. And then finally moving on to the third normal form. So we wanted to remain in that second normal form. We wanted to have the primary keys, and then also we wanted to have our dependencies. So we split these up too. So it was in one giant table. They were separated by data. So boat ID, boat name, seat scaling was of course relating to boats. So they went into boat table. Here's my primary key for the boats table, excuse me. And then you can see there's a pattern here with the island ID, island name, and population. Of course, that's all going to go into the islands table, and island ID is the primary key. And the third normal form, we have our relational data here, relational data between the two tables. So trips is a foreign key, trips foreign key boats, boat ID, and then also boat ID. So we have boat ID here in trips because that is relative to the trip, and it's also relative to the boat itself. And you can see the pattern again with islands, island ID, and then it's valuable information for trips because we need to know where we're going. So that was the relational, the foreign key portion of it. And then here we have the insert statements. So going into boats, and then we have all the different columns here. So boat ID, boat name, seat scale, and then the values are passed in with comma separated values, and the values are dependent upon if it's a varchar or if it's an int, and just separated by commas. And this, again, the same logic applies for islands, captains, and trips as well. Just the amount of data changes from table to table depending upon the columns. So, all right, I will go ahead and jump into the commands here in the exercise. So, first was to write a query showing the captain name, boat name, and a number of passengers for all recorded trips. I'm going to go ahead and run that now. You can see here that we do have our boat name, captain name, the number of people, and the trip ID as well. Okay, second was write a query showing the captain name, boat name, and number of passengers for all recorded trips during the month of March. Okay, so we do have boat name, captain name, number of people, trip ID, and of course these two were conducted in March. Finally, writing a query showing the captain name for a captain that led no trips in the month of March. Okay, if we run that, we can see we just have the captain name here. That was the only information requested in the query, was the captain name, and that's Frank. If we go back over here and see, our third captain is Frank, and the third captain had his trip in July. So that is correct with the name here. Frank was the one that did not travel in March. The other two did. So I believe that concludes this video. Thank you for your time.